I have another question. The next question is the motor tire is inflated. A motor tire is inflated to a pressure of 2.0 times 10 raised to the power 5 Newton per meter squared when the temperature of the air is 27 degrees Celsius. What is the pressure at 87 degrees Celsius, assuming that the volume of the tire does not change? Okay, so this question was asked by WAEC. So we've already solved a similar question like this before. If you've not checked it, check out our other YouTube videos. You're going to check our other collection of videos. You're going to see we've solved this kind of question before, but let us go forward. First of all, one of the first thing you have to notice is that the pressure was given to us in Newton per meter cube. Our pressure was given to us in Newton per meter cube, but that is not the problem. The temperature was given to us in degrees Celsius, so we have to convert it to our Kelvin before we solve. So 273 plus 27 is equals to 300. This 87 plus 273, this is equals to 360. That's our P2 is unknown. So using the formula P1 all over T1 is equals to P2 all over P2, it is equals to now 2.0 times 10 raised to the power 5 all over 300 is equals to P2 all over 360. 2.0 times 10 raised to the power 5 all over 300 is equals to P2 all over 360. That's P2 is equals to 3.0 times 10 raised to the power 5 times 360 all over 300. That's 2.0 times 10 raised to the power 5 times 360 all over 300. This is the question. So this 2.0 times 10 raised to the power 5 is equals to the volume, and this is the 360, and this is it. We'll just cross multiply. This multiply here and this multiply here. So P2 is equals to 2.4 times 10 raised to the power 5. So 2.4 times 10 raised to the power 5. Another question says, before starting a journey, the tire pressure of a car was 3.3 times 10 raised to the power 5 Newton per meter squared at 27 degrees Celsius. At the end of the journey, the pressure rose to 4 times 10 raised to the power 5 Newton per meter squared. Calculate the temperature of the tire at the journey, assuming the volume is constant. So just like we always do, this is our solution. So we'll have that our P1 all over T1 is equals to P2 all over T2, which is equals to 3 times 10 raised to the power 5 all over 300 is equals to 4 times 10 raised to the power 5 all over T2. So when the temperature and pressure should what increase, so it's T2 all over 300 times 4 times 10 raised to the power 5 all over 350 equals to 400 Kelvin. So why didn't you do a conversion here? Why did we use 300 here? Is because it is 27 plus 273. We've already solved this in our similar question. We already solved similar questions like this. 27 plus 273, and that is why we used 300 here. 300 times 4 times 10 raised to the power 5, and the answer is in Kelvin. So if you want to convert the answer to Celsius, you can subtract 273 from here. So with this, you find out that those of us in here that will be studying mechanical engineering, have you found out that this pressure law is consistent with the car tire, with car tire? So let's take for instance now you're going to a far journey and you want to know if your tire is going to burst on the road. What will make it burst and the rest of them? Then you check the pressure that is there and you check the temperature of where you are running, because as you run on the road there will be friction, and friction will increase heat, and heat is going to increase what? The temperature. So with this, you're supposed to know that if you over pressure it, if you add pressure too much, when the temperature increases, the pressure is still going to increase and it's going to mount stress on the tire. You know, pressure mounts stress and strain on a tire, just like we did in physics. Once it becomes too much, the tire might burst, and this is the cause of accident for so many people. You know, we can actually estimate so many people that have died with car bursting, car tumbling, and the rest of them. But if you are a good student of chemistry, you should understand this, that as you go on the road, the temperature is going to increase, and when the temperature increases, the pressure is going to increase, and when the pressure increases, the strain and the stress is going to increase, and when the strain increases, elasticity, the tire is going to get elasted, and then it's going to burst, and then problem go burst.